Welcome back to more linear motion examples. This one is interesting. So we have a car that has an average speed of 80 kilometers per hour for 1 hour. Then it has an average speed of 90 kilometers an hour for 2 hours. What was the average speed for the entire 3-hour trip? So again, there's more than one way to do this, but I think the simplest way is just to look at this and break it down. So the first part of the trip, um, let's say we stop at a rest stop, right? So here's a rest stop. It's got like a McDonald's, right? Mobile, oil station, right? Gas station, whatever. Then you got the second leg of the trip. So you start here. This is the first part of the trip. This is the second part of the trip. And here you have 80.0 kilometers per hour for 1 hour. And here you have 90.0 kilometers per hour for 2 hours. Right, so let's just break this down by sections of the trip, right? The first section, we're going to use our formula. So let's see. V bar is distance over time, so we can write that. Oh, I should have drawn my triangle first. Right? Distance is velocity, or speed times time. Speed is distance over time. Time is distance over speed. And we want to know the average speed for the entire 3-hour trip. So first what we need to find out is what are the distances they traveled in each of these legs, right? Because we don't have any distance information. We know the full trip took 3 hours, and we know two different speeds. So we have to figure out the average. We know the average speed here, the average speed here. We can find the distances. Find distances for the two sections. We know this, I wrote this all up here. Let me just write the formula. So the distance for phase one, or stage one, is just going to be, right, speed times time. And that's going to be 80.0 kilometers per hour times 1 hour, right? And this just gives you, what did I write? One hour. This is going to give us 80.0 kilometers. I'm going to carry through these decimal points till the end here. Now you're really only given one for the, one significant figure for the hour here. But we're going to round everything at the end, I think, is what we'll do. I should have put 2.0 and 1.0. This is my mistake for typing it up that way. So let's use two significant figures for the time. So 1.0 hours. So again, this number is an intermediate number. I'm not rounding it yet. If I needed to report the distance, I'd say it's 80 kilometers. But I need to take these and continue on the calculation. Let's look at stage two. Here we've got 90 kilometers an hour. And that's for 2 hours. I'll try to remember to change this before I upload it. So this gives us 180. We'll just continue to write the extra decimal places, kilometers. So leg one is 80, leg two is 180 kilometers. So the distances in each one are what we calculate here, right? So total trip distance is 80 plus 180 kilometers. This gives us 260 kilometers, right? So our V bar for the trip, right, trip equals the total distance for the trip divided by the time for the trip. So now we've got 260 kilometers over 3.0 hours. Yeah, see, this is, you can see I put the 3.0 and I didn't do that for the other times. So we got 260 divided by 3.0. So here we get 86.666, etc., right? Kilometers per hour. So our final answer is going to be, in this case, we're going to round to two significant figures, right? Because we look at our time, or we look at the information we were given. And again, I meant to give you two significant figures for the times. So I've got 3.0 and 3. So I've got 2 and 3 significant figures. I'm going to round this at the end to 87 kilometers per hour. That's my average speed that I was traveling during this